Welcome and hello. This is a video exercise on HEC ResSim. And in this exercise, we're going to be talking about release gate opening analysis. So if we have a reservoir with a constant release from a gate, from an outlet, and that release is less than the maximum capacity out of that outlet, the question we want to analyze in this exercise is what percentage of that gate should be open or what length should be open to achieve that desired reservoir release. So that's what we're doing in this exercise. What I have on the screen here is an instance of HEC ResSim version 3.3 opened up, and I am in the watershed setup module. So let's go ahead and get started. File, new watershed. Go ahead and give your watershed a name. I'll just call it video 13. And then navigate to the directory you want to save that watershed directory. Select the units, select the time zone, click apply, and then OK. All right, so the watershed's created. I'm going to zoom in, then pan over. I'm going to start by selecting the stream alignment tool here on the left tool menu, hold down control, and then continue holding down control as I sketch out my stream. Let go of control before your last click, and then give that stream alignment a name. Click the computation point tool, hold down control, and then single left click on the upstream part of the reach. And I'm just going to call this CP1. That's called a computation point. Then I'll add a reservoir to this watershed setup by clicking the reservoir tool, holding down the control key, single left click on the upstream of the reservoir pool, let go of control, and a single left click downstream. Call that reservoir 1. And then let's add one computation point at the downstream part of this called CP4. And we're good with that. I'm going to go ahead and create a configuration, new, and then I'll just call this config1. And then the time step will be 1 hour. This is not used by ResSim though, so just enter whatever. Apply and OK. All right, I'm going to go ahead and save that watershed. And then let's head over to the reservoir network module. First thing to do here is create a network that'll bring in the reservoir we just created. So we have to select that config1, and then that should match up. And the network name, I'm just going to call it network1, and then click new. All right, so that popped into place. I'm going to connect the network here by selecting the reach tool in the left tools menu, hold down control, and then single left click on the CP1 junction, and then how to hold down control for that, and then click CP2 without the control button held down. And the reach name, that's fine. I'll just accept that as it is. I'll do the same thing to connect the downstream reach. All right, the fundamentals of drawing out a network are covered in the lessons playlist. So I'm kind of going quick here. What I want to do now is create a inflow at the upstream junction that will then flow into the reservoir. The reservoir will release a constant amount of water. And then I want to build the reservoir pool and then the outlet structures and analyze that percent gate opening. So let's get started with the inflow first. I'm going to right click on the junction, edit junction properties, and then click local inflow tab. I'll just be very generic and call it inflow at CP1. Factor of 1 is fine. Apply and OK. Now I'm going to create a time series data set to represent the flow. And we will choose the month of May 2024. So I'm just going to create a constant flow for that month and then assign it to that junction through the alternative editor. But first things first, let's go Tools, HEC DSS View, and then I'm going to say New. And then I need to create a file. I'll just call it time series data. Okay. And the file's been created. Now let's actually create the time series. We can do so manually by just going manual time series. So now I'll specify the path name parts. I'll call it project, location, flow, 1 hour is the time interval. And then for part F, I'll say 500 CFS. So that will be our release. The start day will be the first hour of the month, which will be May 2024. And then the units will be CFS. I'll come down and click this automatic generate tab. and then type in the units the values of the flow here will be 500 CFS. And then the date time of the end of this time series will be the last hour of the month. So that'll be 31 May 2024 at 2400 hours. Okay, got to click generate first. And there are my numbers. It's a constant 500. I'll click save. And then, no, I don't need to see the data. But I can just confirm that it was created by plotting the 500 across for the month of May 2024. Okay, I'm going to close DSS view and return to that time series in just a bit. Now let's go ahead and edit our reservoir. So I'm going to right click, edit reservoir properties. Here we have the pool and the dam. For the pool, I'm going to paste in the geometry. So we see the elevation goes from 1350 up to 1500 feet, and then the storage from 0 to 50,000 acre feet. All right, so over at the dam, I'm going to go ahead and type in that top dam elevation and then just make up a top length. Then let's add a controlled outlet. All right, so here's the controlled outlet. In a lot of the previous exercises and lessons, I would just paste in numbers like this for the controlled outlet, which shows the elevation of the water surface in the reservoir pool with paired data with the max capacity of the outlet in feet and CFS respectively. Now, this is the maximum capacity. So if we wanted to release that 500 CFS at, say, a guide curve elevation of 1480, well, the max capacity is 1,400 CFS. So we don't really need to open up the gate 100% of the way. Otherwise, we'd be releasing more than twice as much water as we want. And that's what this exercise is about, is now analyzing what percent that the gate should actually be open to pass through 500 CFS if the water surface elevation is at 1480, or 1460 or 1440. It depends. If the water surface elevation is 1410, then the max capacity is 200. There's no way one gate could release 500 CFS. Okay, so let's stick with that and let's go with one gate, which is default. But instead of using these numbers here, let's go and click Edit Gate Settings. And what this does is it allows us to specify not only the maximum capacity when the gate is 100% open, but the capacity when the gate is different percentages open or different lengths open. So Edit Gate Settings, it brings up this dialog box here. Now the default is max capacity only, but now we can specify either the percent open or the length that the gate is open. So I'm going to go with percent, and then I'm going to say 6, so I can go every 20%, including endpoints. So this will be a 0%, 20, 40, 60, 80, and 100. And then I'll click OK. And what that does is, let me make this a little bit wider. What it does is it changes the look and feel of that table for max capacity. So as before, we have the elevations down the left column, but now we have max capacity for each percent gate opening that I defined in the previous dialog box. I'm going to paste in some numbers, and these numbers in the 100% open column are the same that we just saw, but now I have specified 0%, 20%, 40, 60, and 80%. So if the water surface elevation is at 1450, then and the gate is open 20% of the way, it would release 304 CFS. If it's open 40% of the way, it would release 504 CFS. If it's open 100% of the way, that corresponds to 800 CFS. Now, I just made up these numbers, so I'm not sure how accurate that is, but we'll roll with it and see how that goes. Also, we can double click this plot on the right here, and it does graphically show us that the green represents the 0% gate open, red is 20% gate open, the blue is the 40% gate open, and purple would be the 100% gate open. We're going to go ahead and just click apply. I'm going to head over to the operations tab and then create an operation set, operation new. I'll just call this operation set 1. Okay. It gives us the 3 default zones here, and we specify the top elevation of each zone. So I'll do that now. I'll say the flood control zone top is 1500. Click apply. Conservation, I'll start at 1480 feet. Apply. And then inactive zone, the top of that will be 1350. Apply. Okay, and the conservation zone here, the top of which is 1480, will be serving as our guide curve elevation. All right, that's all we need. I'm not going to add any rules to this simulation. We're just going to go with what we have here. All right, alternative edit, and then alternative new. I'm going to go ahead and create an alternative. Alternative one, okay. I'm going to select 1 hour for my time step and just go with the other default settings here. In the operations tab, I'll select operation set one. In the look back, this is the initial conditions that the simulation uses for the look back period. The elevation, I'll start at the guide curve elevation, which is 1480. And then for releases, I will say a constant 500 CFS because that is the constant flow we're going to be sending into our upstream junction here, CP1. And that is also what I specify in this step here. So I have my record here in the table, inflow at CP1, because we identified that local inflow at the junction CP1. So I select that record, I click select DSS path. Now I need to navigate to that time series data set that I created. So let me go open. I believe it's right here. And then here is the record, 500 CFS, and then click this set path name. And that's good. So that populated in right here. Okay, I'm going to save that alternative and save the network. And we're ready to change over to the simulation module. So let's add our simulation and then the alternative so we see our network on the screen. Simulation 1, that will start at, this is the month of May 2024. I'm going to start it on the second hour of the month, and that way the look back period can occupy the first hour. So this will be the first hour, and then the end of the simulation will be the end of, say, the last day of the month is the end of the simulation. Select the alternative and click OK. All right. So we are ready to compute. I'll click compute alternative one and then close. All right, let's go ahead and take a look at the results. Typically in these exercises, I'll right click and plot, but there's a better way, really the only way I've been able to find these results for the percent that the gate would be open is to look at the DSS output table. There's actually a time series that was written during the compute. What I want to do real quick is get an idea of what I should expect that number to be. So let's go ahead and go into the reservoir properties. And remember, our flow rate is 500 CFS and our water surface elevation is 1480. So what percentage, 0, 20, 40, 60, 80, or 100% open should that single gate be to pass through 500 CFS? And it looks like 500 falls between 395 and 655. It's probably a little bit closer to 395. So 20, 40, if this is linear, it'd probably be a little bit less than 30% open. Okay, so that's kind of my approximation, just that thing that engineers sometimes do. So let's go ahead and go to Tools, HEC DSS View. Now in this simulation.dss, we now have a ton of records because we ran a simulation. And as we run more and more simulations or compute routines, we're going to get more and more data. But the easy way to find what we're looking for in the situation is to go to part C, use the filter, and then select percent gate opening. It's conveniently at the very top. And sure enough, we only have one record here. So I'm going to go ahead and open up the table. And here we have our answer, 28.07. Now, this is a constant flow. So every record, every hour of the month should have this same value, and it does. And we can even look at the plot, but it's just going to be a line, and it's at the very bottom here, 28.07. We'll just call it 28.1%. All right, so 28.1%. What would happen if the water surface elevation drops to 1460? So remember, it was at 1480. We had to open up that single gate 28.1%. If we drop the water surface down another 20 feet, what would happen? To pass the same 500 CFS through the reservoir, the gate would have to be a little higher, right? Okay, let's go ahead and answer that question using ResSim. I'm going to go ahead and right click on the alternative new trial. And then I'm going to call this trial 1460 one gate. Okay. I probably could have named the alternative something like that as well, but it's all right. edit run. I'm going to change a couple things. First of all, I'm going to change the guide curve elevation in the operations tab, conservation, and then 1460. Apply. So it doesn't try to fill up on me if I started at 1460, but the guide curve remains at 1480, and then OK. Now I need to change the look back data. So that is here. I'm going to change it from 1480 to 1460 and then save that. I think that's all I need to do because the flow rate's the same. The gate release capacity is the same. I'm going to go ahead and run it. Again, we'll go up to Tools, HEC DSS View. Now I'm going to do the same thing. I'm going to filter on Part C, which is the parameter, percent gate opening. And sure enough, we have a second record. That's great. Here's our first record from Alternative Trial 0. And now we have our new record from Alternative 1, Trial 1. And the number is 34.044% opening. Okay, very cool. I'm gonna actually just rename these so they're a little bit more obvious what we're looking at here. Okay, those are renamed. Let's do one more trial and let's go down to 1440 and see what happens there. Okay, so I'll just create another trial. I will go new trial, 1440, and then right click, we'll edit. And then again, we have to change the guide curve to 1440. Apply, okay. And then we'll change that look back, starting water surface elevation in the reservoir pool to 1440. Save, okay. Okay, compute. All right, so let's go back up to our data set, search for percent gate opening. And now with a 1440 water surface elevation in the pool, we have to open the gate up to 52.4%. So it was originally only open, what, 28%? I'll bring them all up here. Let me rename this one actually. Okay, I got that renamed. Let's go ahead and look at them in the table view. At 1480, this is our first one here, 28% open. When the water surface dropped to 1460 feet of elevation, we had to open up the gate 34.044%. And then when the water surface dropped down to 1440, then we had to open up that gate 52.41% of the way. All right. So let's go ahead and do one more thing to analyze the situation. We'll keep the water surface elevation in the pool at 1440, but I'm going to add another gate. So we're going to have two gates, not just one. All right. So we're going to create a new alternative. I'm going to create a new trial based on this trial, so I don't have to change that 1440 number. New trial. I'm going to name it 1440 feet, comma, two gates. Okay. And now what we have to do is edit that run, reservoirs, controlled outlet, and two gates. Apply. Okay. Okay. And compute. Now we should have another record there for the percent gate. If I select percent gate opening, here it is. And let's go ahead and plot the numbers. Think to yourself, it should be less than 52%, right? 52. So we have two gates right here. So 19%. Wow. Okay, so with only one gate, we had to open at 52% to pass through 500 CFS. But with two gates, we had to open up, it's only 19.38% of the opening. Okay, and I skipped ahead and added a third gate, and that only requires a 12.92% opening at that 1440 foot water surface elevation in the reservoir pool. What we can conclude from this exercise is basically the principles of hydraulics is that the higher the water surface elevation, the less we have to open up a single gate. And at the same time, the more gates we open up, the less of a percentage we have to open all of them up. The user's manual does mention that even though you can enter the appropriate gate settings, ResSim does not currently make use of this information in most of its operations. It will, however, produce a time series of the gate settings as output based on the final release from the outlets. So that's the time series it's talking about here. Well, I hope that was helpful getting everyone up to speed and a simple example with this release gate opening analysis in HEC ResSim.